Any question? No, last week we don't have time for practicing Origin 3. So today I will arrange it for most of the time practicing Origin 3. We still have data transformation. You don't feel cold, you can put your coat on.
Yeah, but it's getting hot in my apartment.
It's fine. Yes, last week we also talked about supervised and unsupervised learning, right? Supervised and unsupervised learning. But for most of you, especially who took to the course of applied statistics, we understand the techniques about regression. On the left-hand side, you can see called regression. And we have regression for supervised learning, or we also have logistic regression. And decision, we have a lot more on the left-hand side. For do the supervised, or sometimes called predictive model, to create predictive model, OLS. Do you have any idea about OLS?
I think it's the least squares.
Yes.
I don't know the whole.
Yes. Yeah, OLS.
Squares.
Least square?
Yeah, I don't know the whole.
Least square?
Square.
Least square. Okay. Let's go. Least square. How about O? People call ordinary. 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 Square. Ordinary. OLS this way. Do you know why people call it OLS, ordinary this regression? Do you know? Do you have any idea about that techniques? Although regression is not so complicated, it's quite simple, right? Simple regression, multiple regression. But do you know why people call it ordinary least square? Do you know why? Because we talk about we want to do the supervised, especially for do the predictive model. Predictive model. Predictive model. Especially for predictive thing, right? Predict number or predict classes, or sometimes we call it label, like predict. But for ordinary least square, this one usually we focus on first part because we try to use predict model to predict numeric value or number. Okay. But the question is why people call it this way, ordinary this way?
I think it's because of the regression formula.
Mm-hmm.
They're using the Pythagoras formula, so it's
Formula.
square.
This way.
Yeah.
But what does this way mean? Really, do you have any idea about this way?
No, because this is the first time I heard about.
You did the first time.
Yeah.
Okay, we didn't talk about this square before, especially in applied statistics. We didn't mention that because I guess assume it's the fundamental concept usually people really understand. Usually, when people start learning basic statistics, right? That's clear. Suppose we have a scatter plot. We have the x-axis and y-axis, and we have a few data: 1, 2, 3, 4, 5, 6, 7. Let's say I have 7 data points on the whiteboard here. How will you draw a regression line?
It's in between the.
Yeah, you can try it. Morning, look up. You can try one regression line that you guess can represent the 7 data points. Okay, that's good. Okay, that's good.
Yeah, the point is it's the closest to all the points.
Oh, okay, thank you. So good. Thank you. Brilliant, how about you? How will you draw a regression line to represent 7 data points on scatter plot?
Scatter plot.
And this is scatter plot. Yeah. We have data point on 2 dimensions, x and y. And I have 7 data points. 1, 2, 3, 4, 5, 7, 6, 7. So I want you to draw a regression line on the scatter plot. How will you draw a regression line to represent 7 data points?
I think I have the same idea with
You will draw the same line?
you.
Why?
Because usually we scatter plot represent the nearest data point in it.
Uh-huh. How about I draw a line? Something like what? How about I draw a line here? How about I draw this line, regression line? How do you think? I draw one line to represent 7 data points on the scatter plot. We will review the idea of supervised learning, especially for regression. And we have different type of regression we focus on now. It's called OLS, called ordinary least square. But we'll try to explain the idea. With how will you draw a regression line on a scatter plot to represent 7 data points?
7 data.
Yeah, you can count here. 1, 2, 3, 4, 5, 6, 7. Would you like to come to the stage and draw a regression line to represent the data point? You know, the first line here, this one, first one.
I can try.
You can try, yeah. This is the second line right here. How about yours?
This one is from Francis.
And 2 is my guess, my educational guess, not all yours.
Oh. Maybe like this?
This one?
Yeah, it's just like my guess.
You guess. Okay, suppose you have some idea to guess the regression line. So what is the main reason?
Because like from my point of view, is like the start point is here,
Uh-huh.
and then like we have 7 points,
Yes?
and this one is like on the top, so
Uh-huh.
this could be like this.
Okay.
In my opinion.
Okay, thank you. Thank you. Ibi, do you want to try? Do you have any different opinion about the regression line?
I think you will like the same with them.
Now we have 3 lines. How about yours?
I choose the second one.
The second one, really?
Oh no, the first one.
The first one? Do you have any reason why you pick first line? Not second line, not the third line?
I think yeah, the right one is the first one. So actually I have no idea about.
Okay,
But
good.
yeah, if I can
Okay.
choose, I will choose the first one.
You will choose the first one. That's good guess. I would like to know the Hazel answers. Yeah,
I also choose the first one.
the first one.
Yes.
Okay. So you do have reason. But
But,
what are the reason?
Maybe for the first one, if I have to change, I will extend the line to the white color.
Uh-huh.
That's it.
That's it.
Yeah.
Okay.
But if I choose the first one,
You will choose the first one to okay. We say to represent or we will say to fit. Now in the data, I think in week 5 or week 6, I start talking about fitting model to a data. We know how we will still talk about this one. Fitting. Fit something into something. We fit model to a data. Here it is get what is our model? It is here. What is our model? You have confused eyes. You know, we fit the model to the data, but where is our model here?
equal A, B, plus
We have 3 lines. Each line represents one model. So here we will get we have 3 models. Right? So it's called model. Regression line is a model. It's the model. And the data, the data we have 1, 2, 3, 4, 5, 6, 7. We have 7 data. So we try to fit the model to a data. We will decide which model is better or more suitable to represent our data set. Right? So OLS, ordinal least square, is still the same idea. Try to fit a model to data that is appropriate to represent our data set. But what is really least square? The question is what is really least square? Since we already removed the third one, so I'll remove the third line here. So I will okay. Next, take the first line as example. First regression line, first model. Model equal to the regression line. We draw, put into onto the scalar plot. We would like to use this line to represent the 7 data points. Okay. So if we draw like this here, that means we have to measure the distance here. So for this data point, what is data point? Alright. So this data point, this is the H. You can see here. This is the actual value. This Y is actual Y, right? This Y is actual Y. But if you move up here, somewhere in here, this called predicted Y. Predict. Predicted. This is our predicted Y, or I will use the Y hat to represent a predicted Y. Okay, do you see that? So this 9 is a represent. Is a regression 9 to represent the actual data, but the Y is predicted here. It's this kind of value, right? And the actual Y is here. So now we have distance, right? We have a gap, we have distance. It means Y minus actual Y. So we have gap, right? We have gap of distance. Sometimes in regression we will call it error time. Right? Error time. In regression, sometimes we call it error time. Error is the difference between your actual Y and your predicted Y. Got it? Do you have an idea? Regression is also trying to predict new number or numeric value. It's predict. It's the predict. Predict is under regression, not here. Okay. So we have this line. It's below. It's below. The actual Y is below the regression line, and this one is actual, right? This also is actual Y. And this also is a distance or gap, right? Okay. So there may be a different way. To find a regression line that is very close to the actual data point. Very close. So if we try to sum up all the gap, we sum up this gap. 1, 2, 3, 4, 5, 6, 7. We have 7 gap, right? If you just sum up the gap, what will you get? If you sum up the gap, 7 gap, what will you have? What number will you have? You know? Guess the number? It's a positive, or it's a negative value, or it's a 0.
Oh, 0 then.
Okay, your answer will be is 0. What else? We have 3 possible answers. Positive number, you sum up all the 7 gaps, or negative number, you sum up all 7 gaps, or only one, called 0. What is your answer? 0, positive number, negative number. Which one? Positive? Why? What do you think of? Okay. But the answer is 0. It's 0. It's 0. is 0. So, for this 9, for this another 9, whatever 9 you draw, you sum up all the gap or the distance, the result will be 0. The 0 cannot make you make any decision, right? Because it's 0, I don't know which one is better. Okay, so that's why people try to square the distance. This arrow turn 1, right? Square. This arrow turn square. This arrow turn square. This arrow turn square. Because it's square, so it never became a 0, right? So we will find the smallest the least square. The square is better. It's better to represent the data. Got it? So it's called least square. The minima gap. Okay? The gap in terms of square. If you did not take square root, you get a 0. No matter how you draw the line, this way, or this way, eventually you get a result of 0. Got it? So this is why I call least square. We have different square, so I find the minimum one. So called ordinary least square. Got it? Have a little bit idea about what is called least square. Right? Okay. So at this point, when people study the statistics, we have learned mean, right? Or sometimes we call it average, right? Call mean of average. And that's easy one, right? People maybe call it X bar or Y bar, something like that. But we learn another concept called variance. We call variance. Variance. Does anyone remember the formula for variance? Anyone would like to write variance for me? Okay. Don't remember, right? Okay. You have summation, right? You have summation. We have original x. This is a variable, right? Minus x bar, the square root, and divided by, right? Got it? Got it. If I say if you did not have square root, just like that, what will you get? You just sum up each data point minus the mean value. What will you get?
I think it's 0 again.
Huh? If I did not take square root, what will you get? I just sum up some value. That's right. That's right. We just find number, that's enough. We use the Likert scale, right? 7 point, 7 point. How about this one? 7, 6, 7, 4, 1, 2, 3, 4, 5, 4. What is the mean value? Suppose this indicator, this the indicator 1, 2, 3, 4, 5. We have 5 value. Try to calculate the mean value for me, please. Would you like please to help me to calculate the mean value for me?
5.6.
So the mean is
5.6.
5.6. Okay, it's 5.6. Let's see. 7 minus 9.6 equal to
1.4.
1.4. Next one,
0.4.
0.4. 0.4, really?
Yeah.
Okay, 0.4. And this one's also 1.4. Right? How about this one? 4. What? Minus 1.6. Okay. So again, minus 1.6. If you sum up, what will you get?
0.
Is it
Yes.
0, right? It's 0, right? So if you cannot take the square root, the sum of the result is 0. You cannot divide it by the n minus 1. This is the same idea. Got it?
No.
Got it?
Engineering.
It's so smart, right? Okay. Oh, excellent. Okay.
That's
Okay.
hard.
So you have to square root and then find the minimum square root. So you call this, right? The smaller one. Small square root to represent the data. This is the same idea. So once we have the variance, but because we can square root, so we will transform into standard deviation, right? So we can understand how spread the data is, standard deviation. Spread what? This is the mean, right? And this is the data point. How spread the data is from our center point, okay? So this point, people have to use the square root, okay? If you take the square root out, you should calculate this one. No matter how you do it, the result will be 0. And then you can do nothing. Got it? Interesting, right? Interesting. Okay. So, it's called ordinary least square, OLS regression. We have another regression called logistic regression. What's the difference? What's the difference between the OLS regression and logistic regression? Could you tell me what's the difference? They both can do the predictive task. Can build predictive model. But what's the difference between OLS regression and logistic regression? Any difference? No? Do you have any ideas?
No.
No? Anyone? Alisa? Ruling? No? No, okay. That's fine. Because we're not so sure about that, right? It's okay. Let me tell you. When you need to use OLS regression, when you need to use logistic regression. Although you have different types of regression, but how do I know which one should I apply? Based on your data type. Okay, based on your data type. Okay. Why? There's data type, also data type. It's X, right? We use X to predict Y. Okay. So if our y is continuous, and you also have continuous s, we call coco, right? Coco, right? It's not a drink. It's called coco. Right? Coco is OLS regression. Okay? Okay, good. If you have categorical y, then you cannot use traditional OLS regression. So maybe you have coca, okay? Coca. Even you have another variable, it's also categorical as your independent variable. You have continuous categorical independent variable, and you have categorical dependent variable. Then you should apply logistic regression. Okay, that's the difference. So that's why we have to learn different model because sometimes our data set is different, and your problem maybe it's quite different, not all the time. So let's go to just a regression, and we also mentioned about the decision tree last week. We just start there, and last we also have explained some idea about unsupervised learning, called segmentation or clustering. Okay, this, how much do you remember about unsupervised learning? Try to remember from last week.
Unsupervised, like something that is not
Yeah.
like categorized or like how to say, like let them learn by themselves. Like we put the information and like then let the machine or ML like learn by themselves.
Mm-hmm.
At supervises is like we have everything for them and then like we put the information.
What do you mean by everything?
Like
Can you point out that key idea?
data.
Data?
Well,
What exactly the data we have that we have to put into the supervised learning?
like something like label.
Label, good. Label. Okay, label about X or label about Y.
About why.
Label about Y, right? Right. So the Y is our target, right? In order to three, Y is our target or dependent variable. And the X is called what? Anyone? Could help me? Some, of course, in traditional statistics we call it independent variable, but in the origin three, how do we call it?
Feature.
Good, excellent, thank you. Called features. Right. We use feature to predict target. If we have target label, then sometimes you mean we provide the data that let the machine to learn, supervise, right? But if you only have features, but don't have any label or don't have any target variable. You don't have any target variable or dependent variable in your data set. You try to do the segmentation. Do you know what is segmentation? segmentation. Do you know what's segmentation?
Defining.
Grouping. Yeah. In marketing segmentation, we have different segments. Consumer, corporate, right? So this kind of segmentation, we try grouping. Then we can allow the machine to grouping for us to generate clusters. Clusters or some type of groups. Clusters or groups for us. So this usually will be the main purpose you want to apply the unsupervised learning. Help you to do the segmentation or clustering on the data set. So maybe you have some class like VIP, for example. We have VIP and non-VIP, right? Something like that, a different group. So we can use different group as a feature then to do the prediction about their purchase behavior. Okay. So this intermediate process usually will apply unsupervised. For example, segmentation, just segment the data into a group and then use the group as a feature to do the prediction, to predict their behavior, okay, or their intention. Okay, that's probably the idea we have talked about last week. Then I would like to switch back to the material. Okay, let's start here, called decision tree. Decision tree also allows you to do the supervised learning. So you still have target, you have label. The label is the value in your target variable. Okay? It's a recursive partitioning. What does partitioning mean to you? When you see partitioning, what does it mean to you? Yeah, try to say it out loud. Partitioning. You know, in Tableau, in BI course, the teacher also will show you how to do partitioning in the Tableau desktop to do the data visualization. The same idea. How much do you remember about partitioning? I have no idea. Do you have partitioning in your computer? Computer storage. Do we have partitioning in your computer storage?
I think so.
Huh? Do you have? Take your computer as example about partition. Storage is what? Is your hard drive, right? Hard drive. Some people do not do any partitioning, so I only have C drive. Right? But some people do partitioning to divide it into C, D, even E, right? With different size, right? Okay, got it? So this is about partitioning means to cut, split. So we split our data points. Data point into different subgroups. At the very beginning, it's a large group, it's a pool. Then we try to pool is mix a lot of information into the same thing. We try to participate. And you can see this algorithm asks a series of questions to purify the data. And it uses metrics like Gini index and information gain. Index and information gain to do the job. And in here, you don't have to understand how can I calculate the Gini gain or the Gini index or information gain. You don't have to do it. You know, the computer will do it for you. They will decide how to separate, how to cut the data into a subset. But what does purify mean? Yeah, Hazel? What does purify mean to you?
I think for the purify is like we need to remove some the air that is not really close or it's not belong to the mass.
Okay, you know, you based on different perspective, especially based on data cleaning. Okay, but in this case here, suppose data already clean. So what does purify mean? Suppose we have data set with different labels. So it's a mix, right? It's a mixed label. Can you give me an example? So that we can purify. The easy way is what? Like this morning, the label should go to class or not to go to class. I want to stay in bed because today is too cold. You know. Also, it's raining. It's giving me a good reason to stay in the apartment. Okay, so go to class or not to go to class is mixed label. So we can put another label into data set. Suppose, let's see, you already come here, right? I can attach table, go to class, go to class, go to class. For those classmates who didn't join the class, not go to class, right? So how can we separate the data? We have 7, right? Grouping, yeah, by what? Yeah, grouping by what? That's good.
Same category.
Grouping by what? This is our target variable. Alright? This is our target variable. And how can we purify target variable or grouping by what? By target variable or by feature? Which one? By target variable or by feature? Yeah, that's the question, right? Okay. The answer is we have to decide by the features. Feature is our independent variable. And that's the result. At the beginning, we have mixed label. We have go to class, not go to class. Suppose we have 10 classmates, right? But we have different features. For example, gender could be a feature, right? And what? Age Could be something else. So there's a lot of features you can use as a criteria to participate. For example, if I have a feature called income, maybe it could be used to do the purifying. If the income is less than 50K, then go this way. If no, go this way. And what does recursive participant mean? Recursive. No? Recursive means it happen again. Recur means happen. Happen again. It means the same feature could be used twice. Maybe at the beginning use the gender, and in the middle, in the bottom, you will use the gender again to separate or to purify the data. Okay, got it? So it's called recursive participant. It's called decision tree. To also do the supervised learning to predict classes. Okay. Okay, there's another one. It's called unsupervised. It's called segmentation. It's quite easy to understand. We have left hand side is it's poor. Okay, let's take 10 minutes break. Take a break. Prepare orange 3. Next section. Prepare it.